The next presentation in this session is on thorium energy R&D in China. This presentation would be made by Dr. Hongjie Xu from the Shanghai Institute of Applied Physics, Chinese Academy of Sciences. And that institute has, from whatever I could make out in the literature, a fairly aggressive program in terms of molten salt reactors and maybe also accelerator-based systems. So may I invite Dr. Xu, please.
Yeah, I see.
25 minutes.
Okay. Okay. Yeah. Good morning. Thanks organizing committees give me an opportunity to introduce our program for the thorium energy. My presentation, the outline as this. First is why TMSR. TMSR is the name of our program. Then is the thorium energy within the TMSR. Then I will brief the status and the progress of the program. First, let me see the challenge to China and one possible solution for this challenge. This is the electricity capacity in China. It's year and now we are here. It's tendency like this. Chinese population is 1.405 billion. So for one person, it's 2 kilowatt. Is so-called the standard for modernization. So it's possible for China is 3,000 gigawatt for electricity. And this is the GDP, 2011. Almost half of the United States. And this slide just shows that about 70% the electricity comes from the coal in China. And this is the CO2 emission. We can see from here, this is 2011. China CO2 emissions almost double of United States. So we can imagine what will happen 10 years later. So that's the environment challenge to China. That's another. The data from Bloomberg last year's is for water. The water's scarcity is very serious for China. This area, most of the economy distribute this area along the core. And the right area and the wrong area is water scarcity, street area. And most of the water have been consumed by so-called the electricity companies. they need a lot of the water, not only for coal, but also for nuclear power. One possible solution is from the Georgia-Ola. It is so-called the Masonic economies. This is very easy to understand. At first is the natural cycle for the CO2. Because of the human being heavy activities, too many CO2 emitted and cannot be absorbed by nature itself, just like this. But if we get help from the nuclear energy, solar energy, the wind, and if we have enough non-carbon hydrogen, we can solve this problem. Now, we just focus on the nuclear energy. This nuclear energy, G4, 1, 2, 3, 4, and 6, the candidate for G4. And why G4? There are many advantages for the G4. But here is sustainable. Sustainable is related for the fuel cycle. Fuel cycle at the moment is mainly the uranium. And efficiency, if we consider whole the uranium, only 1 or 2% percentage. And G4, hope, maybe 10, even so-called Foley fuel cycle. Not only for uranium, but also for thorium. And this is for thorium. This slide just shown by Professor Carlo Lubia. It's your slide copy. I get it several years ago in Shanghai. Please with my name. Yeah. Your name here. And just to show here, this is the data for the thorium, but without Chinese data. But this is estimation given by Professor Carlo Lubia, how much of the thorium China will have. And this is I'm sorry. This just show how to use thorium. And the main result is very clear. And molten-salt reactor is very suitable for the usage of the thorium because of the many reasons. And then that is our program, TMSR. I will like show this slides. This just shows that 40 years ago, China began the TMSR program. This began from our institute. We have built a small reactors, molten-salt reactors. The aim to use thorium. But because of limitation of technology and industry at that time, this program changed from molten-salt reactor to the light water reactors. And 40 years later, Chinese Academy of Sciences restart this idea. And we have the new program for the thorium molten-salt reactor nuclear energy system. We call it TMSR. And aim of the TMSR is to develop the thorium energy and non-electric application of nuclear energy. Based on the TMSR liquid fuel, we call it a liquid fuel, and the TMSR solid fuel. during the coming 20 or 30 years. The program initiated by CS from the 2011. And here is, this is Chinese. TMSR liquid field normally is MSR, is the so-called traditional MSR. And TMSR, I'm sorry, this solid field is in United States is a FHR, fluoride salt, the high temperature reactors. And TMSR focus on two points. One is so-called thorium-based fuel, and another is fluoride cooling. This the advantage is for the thorium energy shown here. For another one is safety, high temperature, and water-free. And following is we will focus on the thorium energy in this program. This is so-called the fuel cycle mode. Here is three. United States, American scientists recently proposed the four. Just here is one through. Now it's a mainstream of the fuel cycle. Then is the alternative one through fuel cycle. This is the four. This normally means deeper burn. Deeper burn means you can make some modification for the fuel, for the maybe reactor technologies and so on. Make it the fuel have the deep burn. No process. Modify open fuel cycle. That means there a little process. And this is the fall cycle. Consider this full mode. Our TMSRs, mainly the mission is reactor and applications. For thorium energy, we will develop two kinds of the reactors. First of all, the so-called solid field. Solid field mainly focus on the so-called one through or the alternative one through. Mainly, that's because it's based on the tracer field. Tracer field can make the burn very deep. Then is so-called the liquid fuel. Liquid fuel, you can do some process online. You can make some separation for the production, fission productions for such as the PA233 and so on. And also you can add some things if you need it for the operation of the reactors. And this is the whole scheme of our program. The fuel cycle, this is the so-called the solid. Solid field mainly focus on the, I just mentioned, is water-free. Because in China, a lot of the place needed primary energy. And this area, almost no water. And also, they want to build the reactor underground for the safety, for the security. And for thorium energy, we use it as for the starting point to get more the knowledge and the technologies. Then we will build a focus on the liquid field. Liquid field reactors, nowadays, there are many limitations for the development of the technologies, for the aspect, the reason of the safety and so on. And also we consider so-called the two kinds of the reactors. One is for the breeder. Breeder is a traditional idea. Another one is for the burner. burners sometimes maybe you need help for the outside neutron source, is so-called ADS. Maybe other. Maybe now there's some research program for the laser, the neutron source. Maybe if you had very strong lasers can produce enough neutron, still can use for the outside, alternate, the neutron source to help for this burner. And FHR can be considered a precursor to the MSR. This mainly considered technologies, easy and difficulties. So this is the roadmap of our program. The first is for the TMSR, for the solid fuel. Solid fuel is mainly integrate many major technologies from the reactors and focus on the application of the high temperatures, the non-carbon hydrogen productions, and so on. Later is a focus on the long term. Just as Professor Louvier said, more than 1,000 years, the human beings don't worry about the energy. So it's a long term. And we start our program from very beginning. Sometimes we developed some ability for the molten-salt reactors, the reactor design, and for the molten-salt chemistry and the technologies, looping technologies, and also we developed some material technologies dedicated for the molten-salt. And also we have the dedicated the chemistry, such as a parallel process and so on. Then, following is the contents we make research on in our program. I just show because of the time. Now, finally, I brief the status and the progress of our program. This is the schedule, a time schedule of our program. This timeline here, we start 2011. This time means the financial support we have had and we will have. This first stage, the first stage, we have had the financial support from the government. It's about $400 million US. And this some of the main applications and main aim of our program. We plan to build two kind of the reactors. First stage, we just plan to build the 2 megawatt the experiment reactors used for the next steps experiment. And for the next step is 10 years. Recently, we have a progress. We aim to the upgrading of the program from the CS to the national. In China systems, CS have the special program. But if you going up, it shall be get support directly from the national. Recently, this program have been listed in the Chinese Energy Bureau, the program listed. Then, this 10 years, we have 2 steps. First step, we combine with the CS programs, aim to build one is 10 megawatt the solid field reactors is a pebble bed. And 2 megawatt, the liquid field, the reactor with the ability for the online separation and the parallel process. Later, we plan to build the 100 megawatt solid field for the demo most of the technologies integrations, and for the industry application of the high temperature, of the hydrogen productions, and so on. And also, we will build 10 megawatt, the liquid TMSR, with the full scale of the online separation parallel process, focus on the Thorium applications to demo how the procedure. Then another, this is from 2025 to then later, just considering. If we can success here, I think no problems. We can get support. For solid field, the industry will come in, and they will invest it for the new reactor. And for liquid, we still need the financial support from the government, both from the industry. And actually, recently, 2 of the very big, the industry will show their intent. They intend to join our program, make some contributions. And then this following is the team and organizations. Because this program started 3 years ago, now we have the, we have the team, more than 400 permanent staffs. And most of the is very young, about 30 years old. And this, the structures, about 10 institutes of CS engage in our program already. And later, some more the companies and university and industry institute will engage in again. We have signed the MOU with the United DOE of the Americans, dedicated for the Molten-salt reactors, mainly focused on the Oak Ridge peoples. And we have some progress. I just show here. This is the preliminary physical analysis for the Thorium fuel, the cycle based on MSR. And also the analysis of the other kind of the proposed reactors, such as traveling waves reactor proposed by American scientists and EM square and so on. We compare with several kind of the reactors. We show some preliminary result here. And also, we have finished the first the reactor design, and we should finish for the coming 3 or 4 years for construction of the first experiments. The reactors, there's some the parameters of the, and later this is some design result in neutron flux and the power distribution and so on. This is for the sensitivities on uncertainty. And we have started design the 100 megawatt of the solid fuel TMSR. And also we have tried the 1 gigawatt pre-conceptual design for want to know more about physics and chemistry and some scientific problems. And then there's in the development T-based fuel. We have 2 kind of fuel, and just show one is the solid fuel, is tracer field. Tracer field is for the MSR, is shall need some modifications, and still we have the liquid field. We will show all the here. And this, although we compare with two kinds of the fuel, advanced fuel, and we compare with the temperatures, burn up, power output, and nuclear waste, and so on. This some tracer. And they have a roadmap here. This is for the liquid field. Liquid field needed the ultra pure, the thorium compounds. And this is some labs we have built, and we have got the result here, the fine line for the thorium. This is the so-called the fuel cycle for the flow sheet. And this aqueous flow sheet, fluorine pyrolysis, we have tried several methods, and also we have collaborated with the United States. Recently, we employed the possible collaboration with Argonne people, with Idaho people, and with the Alkali people for the pyro process. This some result we have got. This will also make some feasibilities from the calculation, from the modeling for the aqueous process of the start. Because 40 years ago, American scientists make a lot of effort to develop such kind of technologies. But all the aim is based on the fluoride salt. It's different. So both sides they're interesting to collaborate for next steps. Okay, I just give some conclusion the presentations. We now the TMSR gets the support from the government, of Chinese government, just because China face the very serious challenge, not only for energy, but also for environment. And we have had the preliminary progress, including for the organizing team and built the laboratories, and also we have had the financial support already. During first 5 years, we have the $400 million US dollars, mainly focused on the built the basic research facilities and so on. Later, maybe we can have maybe $2 billion US dollar for the whole facilities we just described. We want to build, and also we will have the new set. It's 300 away from the Shanghai for our the so-called hot the campus for the coming the several experiment and the demo reactors and so on. And this program is a long-term program. Maybe we can get the 10 or 15 years financial support. I'm not sure for long term. I think mainly depend on the result, how much we can get, and how success we can make. Okay, thank you.
Thank you, Professor Xu. That was a very interesting exposition of the Chinese program related to thorium. We can take a couple of questions. Yes, please. Can you get the mic? Oh, the mic is already there? Okay.
Hello. Hello? Yeah. One question. Very impressive. Thank you very much for the presentation. I was wondering, when you're designing these reactors, are you addressing it for export use also? Are you looking into regulatory requirements outside of China when designing it? or is it purely a domestic program?
I'm not sure. What's your outside? Export to other country?
Yeah. The reactor technology.
If we success, we will lack. And actually, during we discuss with American scientists for the collaborations, my boss proposed we can have the joint venture for the future. Because maybe you know that TMSR technologies is mainly used for the peace applications of the energy and the environment. If we have some progress and we success, we will like to export, of course.
Yeah.
we will like share.
Can we get one from here?
Okay, I was going to ask this question from Professor Rubia, but we're talking the same line, so MSR reactors, so I ask you as well. From the Fukushima accident, we know that accidents can happen, and bad luck is beyond reach of the science and technology. So the question is, in the MSR reactor system, we have fuel already molten fuel. So this one-step barrier which exists in the metal, in the solid fuel step, already we've deliberately made it liquid ourselves. So the point is, if your reactor vessel ruptures, what will, how massive amount of radioactive material, iodine, etc., will release to the environment. It doesn't matter if it's above ground or underground. It's the same issue. So they're looking at the water leakage from the Fukushima thing, which all the underground reactor water was polluted, etc. So what's the solution for this problem?
I think your question is that the first is for the Fukushima accident. Then is for the so-called leakage of the radioactive materials. First, Fukushima accident just based on the so-called old reactors. No. You can make a research. Human beings have many chances to do for that events. That's all. And later, I just show that MSR is water-free reactors. They don't need the water. So, at the moment, most of the reactors are based on the coolant. Coolant is light water. If some accident happened, the water will leak, will mix with the water. That's a big problem. But molten-salt, there's some data, you can know that, is not active with the water. And also, if the temperature down, the salt not melted, is solid. You can store. You can put in some existing concrete, some power and some place. I think that's all.
One last question. Okay. It's on the same thing? Yeah. Okay. Professor Rubia. Can you get the mic here?
We have already. Okay.
Yeah.
Well, I have some very strong reservation on the idea of using molten salt with the fuel in it, the one you mentioned there. Because if you look at carefully, you realize the amount of radiation that is involved in the molten salt is very, very large. Because you have all the uranium, all the thorium, all the minor actinides, all sitting in a liquid form. Now, the liquid form has no shape. It depends on waves, oscillations, etc. And therefore, to guarantee the absolute constancy of K, is not trivial at all. Remember, with this material, the difference from critical to ordinary K is 0.2%, because there is very small difference for thorium. Therefore, under those conditions, I will consider that to have a liquid in there, which can have any shape in condition things, is a real problem, and gives you absolutely no advantage. It seems to me that the solution I gave at the beginning, in which you still use rods, you still use standard fuel and everything else for the system, but you use, instead of using molten salt, molten metal, using molten salt, is a perfectly legitimate solution, which is much more conservative, resolve completely the problem of having online purification, which is representing a lot of cost, a lot of complexity, a lot of problems. So I see that your scenario is a bit too complicated compared to what you really need to do that. So I don't think that I would be of the opinion to make ordinary system, but not making it out of lead as I did in the famous CERN program, but use molten salt instead. But standard molten salt, LIBEF. Thank you.
Thank you. I think we are really running out of time. You had raised it. So one last question, and then we'll move on to. I think Dr. Kadi had raised a hand quite early, but I didn't give him the chance. So if you agree, we'll take him first.
Yeah. Okay. So may I ask you a question concerning your changes in your program schedule? So originally you planned to build 2 megawatt molten classical liquid fuel molten salt reactor in the end of this decade. Yeah. So what is your argument to skip this plan? I mean, to continue and to first liquid molten salt reactor at 10 megawatt. What are your arguments?
Actually, in my presentation, I have mentioned the reason for this. Because of the Thorium energy, based on the classical modern salt reactors in long term, I think in the world, almost any government will lack support. One program, no result for almost several tens years. And the solid field MSR is so-called mainly focused on the high temperature output, is for the non-electricity applications. It's a near terms program. I think you know that very well. That proposed by American scientists, mainly focused on the high temperature applications. And both have the same technologies requirement. For the molten salt, for the material, for the design of the reactors, almost same, but different. The difficulty is different. So that is the main reason we make the modification, not change. From beginning for the only long term, and change it to the both near term and long term. I think that's all.
Yeah. Okay. Last question.
Yes, Kadi from CERN. A question concerning your the molten salt cooled solid reactor. So looking at your data, what you presented for the gigawatt machine, so the ultimate machine, you were quoting a power density of 10 watt per centimeter cubed. So this, I suppose, was the parameter used for the gas-cooled high-temperature reactor. So now what I have a hard time understanding is the motivation to go for a molten salt cooled. I would have imagined this would have given you the opportunity to increase the power density of the reactor.
Yeah, actually, this the topic is not focus of our presentations today. That's another story. I just mentioned that the high temperature, the fluoride high temperature reactors proposed by American scientists based on the trisol, the fuel. And the big change is that the change the coolant from the helium gas to the molten salt. They have made mainly the analysis, they are mainly the advantage for this change. And I just show that we have make our own the research. Okay, that's all.
Okay, I think with this, let's thank Dr. Xu for an interesting presentation about the Chinese program. And can we move on to the next paper? Thank you, Professor.